As I explained earlier, whenever the source or the observer move towards each other, the observed frequency increases, which means the observed frequency is greater than the source frequency. The reverse is also true. If the source is moving away from the observer, or if the observer is moving away from the source, then the frequency that the observer detects is going to decrease, which means that it's going to be less than the frequency emitted by the source. Now let's see this one basic formula that you can use to solve Doppler effect questions. FO equals to Fs times V plus minus VO divided by V plus minus Vs. You already know what FO is. It is observed frequency. Fs is the frequency of the source. Here V is the speed of sound, VO is the speed of the observer, and Vs is the speed of the source. Now the problem is you have to choose which signs to use. So let's see the basics of fractions, which have a numerator and a denominator. If the numerator increases, the fraction also increases. If the numerator decreases, so does the fraction. But the denominator is the opposite. When denominator increases, the fraction decreases, and when the denominator decreases, the fraction increases. So let's see an example where the source is moving towards a stationary observer. So we have already established that when the source moves towards the observer, the observed frequency increases, right? Since we have a stationary observer, the speed of the observer, VO, is 0. So now the speed of the source, Vs, is in the denominator. If FO increases, should the denominator increase or decrease? Decrease, right? The only way we can decrease the value of the denominator is to use a negative sign, and this becomes your formula for the specific case of a moving source towards the stationary observer. Let's see some other examples in the next video.